This is the intro video for the DC Circuits lab. Because we're going to be using multimeters this week, and these guys can only take a maximum current of 400 milliamps, the first thing you're going to want to do is limit the current that's coming out of your power supply. So if you've done the IV characteristics experiment, then you've already seen this next bit of video, but here it is again to refresh your memory. The power supply you're probably going to be using in this lab is the Xantrex 60-1. We're going to be using these three terminals exclusively. Another thing you need to do with this Xantrex 60-1 is you need to connect a short wire between the ground terminal and the black terminal and leave it there for the duration of the experiment. The problem we have is that these multimeters that we're going to use are only rated to 400 milliamps. So that means that this guy is quite capable of burning out the fuse in these guys. We're going to limit the current that this power supply can put out. The way in which we do that is you start by turning the current all the way to maximum. Then you want to set your voltage to 12 volts. Next, you take another wire and you connect it between the positive and negative terminals. And notice that as soon as you do that, the voltage goes to 0. Now we're going to adjust the current to a maximum of 0.4 amps. Then we can remove this short wire that we put across the positive and negative terminals. And then once you've done this, you don't touch that current knob again for the duration of the experiment. You're going to be using your digital multimeter to measure resistances, voltages, and currents this week. So I'm going to give you a quick tutorial on how to do that. To measure a resistance, which is what you're going to be doing first in this experiment, you're going to plug in across these two terminals, and you want to set the scale to the ohm meter scale. As I said, you plug in across these two terminals. Those are the same two that you plug in for a voltage measurement. So to measure a resistance, you simply plug in these two terminals across whatever you want to measure the resistance of, and you should get the value directly on your scale. Now, one thing to know about measuring resistances is that there can't be any other power supply attached to the resistor, because the way in which this works is it puts out its own current, and if you've got some other current flowing in your circuit, then this device will get very confused. So just make sure that you disconnect all power supplies when you're measuring the resistance of something. To measure the voltage of something, and we are specifically measuring DC voltages this week, you want to go to the V with a straight line over top of it. And again, you're going to plug in across these two terminals for a voltage. Make sure that you go from positive side to positive side, and negative, the common terminal, to the negative end. And then you should directly get your voltage on the screen. To measure a current, you're going to want to go to the milliamp scale or the amp scale. This week we should use the milliamp scale only. As I said, you're going to plug in across these terminals on this side. Now, because we're using milliamps, we'll be in the milliamp slot rather than the 10 amp slot. So we'll use these two. So here is a simple circuit that has current flowing in it. So I've got a battery and a resistor, and it's just all hooked up like this. Now, if you want to measure the current flowing into something, you have to interrupt the current that's going into a circuit element, like a resistor, force it to go into the ammeter, and then once it's been through the ammeter, you allow it to continue on where it was supposed to go. So the ammeter effectively becomes part of your circuit in that we interrupt the current that was going in here, forced it to go through the ammeter before it was allowed to carry on where it was going. So the first thing you're going to do in part A of this experiment is measure the resistance of each of your 5 resistors. So you'd grab each of these guys and measure its resistance with your DMM. Now you may be wondering why we're bothering to measure this given that it says what it's supposed to be, but the fact is this is what the manufacturer told us that the resistance was supposed to be. The DMM will give you a much more accurate value with an uncertainty of 0.1% rather than an uncertainty of about 5%. So that's why we use this value rather than the one that's on there. Next, you're going to do some calculations. You're going to use the resistance values that you just measured and a voltage of exactly 10 volts, and you're going to calculate 4 different things. So the first thing you're going to calculate is the equivalent resistance of all of these guys. In other words, if you replaced all of these guys with just one resistor, what value would it have to make the current drawn through this circuit be equivalent? So you calculate what the equivalent resistance of all of these guys would have to be. I find it sometimes useful when you're doing those sorts of things to redraw your circuit a little bit and say to yourself, okay, This one and this one are in series, so you draw them in series. And together, they're in parallel with this one. So there's the two in series, they're in parallel with this guy. And then those three are in series with this one. So 1, 2, 3 in series with this guy. And then all of them are in parallel with this one. So all of them are in parallel with that one. So you may find it useful to redraw something like this in order to help you better understand how to calculate your equivalent resistance. Then you're going to calculate three more quantities. You're going to calculate I1, which is the current flowing through resistor 1, and also I5, which is the current going through resistor 5, and also the voltage drop across resistor 3. And by the way, I find for getting this first one, the current through R1, it's sometimes useful to calculate the equivalent resistance of all of these guys and consider that to be in parallel with R1, and then you just need to figure out what the current down R1 is. For getting the current through R5 and the voltage drop across R3, however, it might be more useful to go back to this and say, okay, I want the current through here and the voltage drop here. And finally, you might consider actually doing these calculations algebraically before you come to the lab. You don't have to, of course, but it would save you time during the lab period, because then all you'd need to do would be to substitute in your measured values of the resistances. So now you're ready to build your circuit, but for now you're going to leave out the power supply, so you'll just have two wires dangling here. The reason why is we want to measure the equivalent resistance of all of these resistors, and remember you can't have a power supply in the circuit if you want to correctly measure a resistance with the DMM. So you build all of this stuff, and for now just leave out the voltage supply. And I find that it's easiest when you're building circuits to just work your way sequentially around one loop, and then add the next loop and then the next. So this circuit is this mess of wires. And now I'm ready to measure my equivalent resistance. And by the way, I left out the switch down here just because we don't really need it for this. But I've hooked up everything except for the power supply and the switch, and now I measure the equivalent resistance of the whole circuit via these two wires. So I make sure that my DMM is set up to measure a resistance, plug in across here, and it should just give me my value for the entire circuit. The next thing you're going to do is set your supply voltage to 10 volts, but we're not going to trust this number because it's not accurate enough. So we're going to use the DMM, which gives a much more accurate value. So at this point you should have already current limited your supply voltage so that you can't burn this guy out. And if you're using the Xantrex 60-1, then you also need this cord here connected between the green and the black terminals. So to set your supply voltage to 10 volts, you make sure you're plugged in across the correct two terminals for voltage, and you make sure you're set to the V with a straight line over it, and then you just hook across the black and the red terminals with your voltmeter. And I've obviously got them hooked in backwards because I've got a minus sign, but this is still good enough for me to set it to 10 volts. And so now I'm going to, as carefully as I can, try and set it to 10 volts according to this display, not this one. And this will be a little bit hard to do just because this is not really a fine enough adjust, but you should do the best you can. And once you've got it as close as you possibly can, you're going to use this value in your calculations. So it's not exactly 10, but I can't get any closer, so I would use 10.013 in my calculations. Once you've set your voltage, you don't need to touch your voltage knob again for the remainder of Part A. So here's that same circuit, and I've hooked up the power supply now, but it's off screen just so that it doesn't get in our way. And so now you need to measure three more quantities. You want to get the current flowing through R1, the current flowing through R5, and the voltage drop across R3. Now measuring currents with ammeters is always a little confusing, so I'll just go through this. First of all, set it up to the milliamp scale. And remember, if I want the current going through this guy, I have to hijack the current. So I take this, which is feeding current into him, and I put it over here into my milliamp scale, and then once it's been through the ammeter, then I allow it to continue on to where it was supposed to go. And then to get my current, I would just press down the tap key and measure it directly. Likewise, with getting the current through R5, you would come over here and you'd say, okay, the current's feeding into R5 here, so I hijack that. I plug it into my milliamp junction, and then once it's been through the ammeter, then I allow it to continue on where it was supposed to be. And again, press the tab key to get a value. Measuring a voltage, however, is always a little bit easy because you just plug in your two wires across the two terminals of whatever it is you want to measure. So you switch to the V with a straight line over it, plug your two cables into here, and then just plug in directly across the circuit element that you're interested in and push down your tab key. So voltage, you plug in across the two terminals. Current, you have to interrupt the current flow, feed it into your ammeter, and then once it's been through the ammeter, you allow it to go back to where it was supposed to go. In part B, you again start by measuring some basic quantities. So you've got 3 resistors you're going to be using, different ones than you used in part A. So you use your DMM to measure the resistance of each of these, and then you also want to use your DMM to measure the voltage of your dry cell, your battery. Next, just as you did in part A, you're going to be calculating some values using the resistance values that you just measured and also the voltage of the battery, which you also just measured. This will be the Xantrex power supply set to 3 volts. You're again going to be calculating 4 quantities, and then later you'll build the circuit and measure those quantities and check whether you got good agreement, just like in part A. The 4 quantities are the current through resistor 6, the current through resistor 7, the current through resistor 8, and also the voltage drop across this part of the circuit from this point to this point. And I'll just point out that this leg of the circuit is actually connected in parallel with this leg and also with this leg. That is, they're just connected by bare wires. So that means that the voltage across these 2 points is exactly the same as the voltage across these 2 points and these 2 points. So in your calculations, if you're finding it hard to find this voltage, just consider that there might be other parts of the circuit that are equivalent and which would be much easier for you to calculate. You're going to be using Kirchhoff's rules to calculate your currents and your voltage in this circuit. So you'll want to identify junction points, that is a place where more than 2 wires come together, so for example 3 wires here, 3 wires here. You'll also want to assign current directions. So you might say that in this loop of the circuit, the current's going in this direction, so from here around this way. However, there's something you need to take into account, and that is that you have 2 power supplies here, and they're kind of fighting each other. So this one would tend to move current this way, and this one would tend to move current this way. Well, the nice thing about Kirchhoff's rules is if you assume that the current's going in this direction, and it turns out you're wrong for one resistor, say here, then that just means that the current you calculate through this resistor will end up being a negative value. So you're free to go ahead and choose whatever current direction is convenient. Now, when I use Kirchhoff's rules to solve a circuit, I usually try to choose my current direction in one loop and the other loop to have the same direction in the one leg of the circuit that they share. And again, if I'm wrong in any of my choices, it just means that I'm going to get a negative sign later. So that means I would choose my current direction like this, here, and like this, here. And then I could start setting up my equations for this loop of the circuit, and for this loop of the circuit, and also for my 2 junctions, and then I could solve those equations to figure out my 3 currents, and eventually my voltage across here. Now again, this is something that you could work out algebraically before you come to the lab, but you'll note that in the lab manual it does say that you need to provide all of your work, so you need to show everything. So if you do work this stuff out ahead of time, just make sure you bring that with you, because you'll need to hand it in with your lab report. So next, you build your circuit. So here are the 3 resistors. The middle one is connected to the battery, and then the power supply is again off screen. And just a reminder that you set your power supply to 3 volts using the DMM. So don't trust the power supply's display, trust your DMM. And then you should be ready to take some data. Now, one thing that's a little confusing with this circuit is, if you take a look at this diagram, there is actually one loop of the circuit which is complete right now, even before you push down the switch. So you will find that when you take measurements in this area, you may actually get a current even when the switch is not pushed down, but that's not the correct value until you've pushed the switch down and completed this second loop. So just don't be fooled by that. So you're going to measure the current through these 3 resistors. And remember, when you're measuring currents, you want to hijack the current that's going into the circuit element, force it into your ammeter, and then once it's been through the ammeter, you allow it to go on to where it was supposed to go. So you'll measure the current through all 3 of these, and then you also want to measure the voltage across these 2 points. And again, remember to always push down the tap key before you take your measurement. And also remember that for every experiment, you should always go back and reread the objective before you write up your analysis in your report.